Okay, so let us start. So, in general, why we need to use these solar panels, why this technique arised and developed now, all these came from the necessity to have some renewable energy sources. Why we need these renewable energy sources? So because during last decades, this question become crucial for being able to reduce the amount of CO2 we are pumping into the atmosphere and oceans, and it means that we need to be able to mitigate dangerous levels of climate change. Climate change mitigation is a huge concern for governments around the world nowadays, and with an ever increasing energy demand also, especially in newly industrialized countries. So, hence, we need to look for different ways of producing energy that is sustainable for future generations. And also, we have to mitigate the following challenges, such as global warming, ocean acidification, sea level rise, ice sheet mass, and glacier retreat. So I think all of you know what all of this is. So, for example, if we speaking about global warming, it means that the Earth average temperature has risen by 1.1 Celsius degrees since the late 19th century. So most of this warming has occurred in the last 35 years, even at the fastest rate in recorded history. Global warming occurs when carbon dioxide and other greenhouse gases collect in the atmosphere and absorb sunlight and solar radiation that have bounced off the Earth's surface, and all this become possible due to intensive exploitation of natural resources by human beings. So normally this radiation would escape into space, but these pollutants, which can last for years to centuries in the atmosphere, they trap the heat and cause the planet to get hotter. So it's so-called the greenhouse effect. So all this comes from intensive development of technologies. Even it started with development of industry in the late 19th century, and now we use the natural resources more and more intensive. So that's why this greenhouse effect strengthens. Also, this global warming, it also impacts on the water level, on the ocean level, and other nature-related processes. So, such as ocean acidification, it's when carbon dioxide reacts with ocean water to produce acid or carbonic acid. So, it means the lowering the pH level of the ocean, making it more acidic. And when conditions are too acidic, corals cannot absorb the calcium carbonates they need to maintain their skeletons, and they dissolve. So this is also known as coral bleaching and results in the loss of vital reef habitats. So which is home to thousands of species for marine life. And the carbon absorbed by ocean surface layers is increasing by 2 billion tons every year, and coral reefs are suffering ever increasing levels of bleaching. So also, this global warming, its impact on sea level rise. So according to statistics, each year ocean level rises by 3.2 millimeters, something like this, due to melting ice sheets and the thermal expansion of water. Also, it impacts on ice sheet mass. So Greenland and Antarctic ice sheets, they decrease by 413 gigatons each year. So it's very significant amount. Arctic ice, it decreasing by 13% each decade. And also one of these main features of this global warming and the necessity in development of novel energy sources is the glacier retreat. Glaciers are retreating around the world practically, particularly in the Alps, Himalayas, Andes, Rockies, Alaska, and Africa. So all of these are consequences of global warming, of the intensive use of technology in the industry during recent maybe 3 or 4 decades. So all these are results of these activities, which I all just identified. And this industrialization, it mostly relates to the intensive use of fossil resources. So thus, there is a necessity to find maybe some novel approaches to energy extraction in extraction now that should be not that harmful to environment comparing to the current situation. So in this regard, different sources of so-called renewable energy was considered during last maybe 50, 70 years. And on the world scale, the potential of renewable energy is could be represented as within this small chart. So it could be used different types of renewable energy sources, such as biomass, hydropower and wave energy, geothermal energy, wind energy, and some others. But from this chart, we can see that the most potential source of renewable energy is a solar energy. So that's why we have to consider this type of energy the first of all, and we have to understand how can we use it, which benefits could it provide for us, how it works, and all this we will discuss in our next in our following slides. So solar energy, it could provide two main benefits from its use. So systems which build up with the use of solar energy, they do not produce air pollutants or carbon dioxide, so we don't impact on these greenhouse effects that much. And also systems on buildings have minimal impacts on the environment as a consequence from the first feature. But still, solar energy has certain limitations, such as the amount of sunlight that arrives at the Earth's surface is not constant, and the amount of sunlight varies depending on location, time of day, season of the year, and weather conditions. Also, the amount of sunlight reaching the square foot of the Earth's surface is relatively small, and this leads to the necessity of a large surface area to absorb or collect useful amount of energy from the sun. So these are two main limitations with the use of solar energy. So first is that sunlight doesn't arrive to Earth 24 hours in a row. I mean, in one certain place on the Earth, in one certain location. And another one is that we need relatively significant areas to collect all the energy which arrives from the sun. Solar energy could be used, not could be used, but solar energy currently used in two main ways. First is the use for solar thermal power. Typically, it's used to heat something, and typically it's used to heat water. And the second option, the most popular option, is the use of photovoltaic technology to produce electricity from the sun energy. And in our regards, as a computer technology specialist, we have to consider the second option first of all, because computer technology is based on the use of electric energy. Solar power is generated directly from sunlight, so-called photons. I hope you know it from physics. And solar thermal panels, they are filled with water. So this first option, they are filled with water, which heats up in the sunlight, and the heated water is then pumped through a tank, heating the water that is connected to the taps in the house, and that's why we can get heating system or hot water in the house with the use of solar energy only. While the second option, photovoltaic cells, they use the sun's energy to convert and then may to convert it to other forms of energy, and they are made from two layers of silicon crystals. In brief, the principle of their operation is the following. When photons hit the top layer of silicon, they excite the negatively charged electrons in the silicon atoms, giving them enough energy to move towards the positively charged lower layer, and this all induce electrical current. So direct electrical current, and we discuss it a little bit later in the following slides, and maybe we can see some picture how it works. So the popularity of photovoltaic cells could be confirmed by statistics. So for example, 3.4% of total electricity was generated by solar photovoltaic in the United Kingdom 3, 4, 5 years ago it was, and it was 29% of entire renewable energy produced in the United Kingdom of those years. So you can see that 3.4% of total produced energy is not maybe that much, but from statistics, for example, for Germany, they could produce about 19% of the total energy received only from solar panels, from photovoltaics. So let's consider this example further about the United Kingdom case, because I think this is one of the most close example to Latvia geographically with the solar energy distribution. So, for example, they consider that their solar potential while the sunniest part of United Kingdom receives much less solar radiation than the sunniest part of Europe, while the south of this country, they has comparable sunlight with that of Central European countries. I think maybe more or less this goes to Latvia. Solar power has no fuel costs. It does not produce greenhouse gases and can provide electricity to remote areas. That's why it is considered in the United Kingdom, in Germany, and in other industrial countries as one of the possible sources, main sources of energy nowadays, even for industry. But however, because photovoltaic cells, they require rare metals like cadmium and indium, they are very expensive, and that is could be considered as another limitations in their mass usage nowadays. So for example, the average house in the United Kingdom, it uses around 3 kilowatts of energy each year. So it means that you could cover this need kilowatt hours of energy each year. So it means, yeah, so it means that you could use about 12, 15 photovoltaic cells to generate this much of power. And Here we come to another limitation that with the solar panels, why they are not still massively used at households, because they're not much efficient. Average typical efficiency of solar panels is about 15 to 25% of the sun's energy. They could convert it into electricity. And it also added value in cost of solar energy production. So, as we already told, one of the limitations is that solar energy is not available 24 hours per day. It depends on sun intensiveness, and also it could produce better performance during noon hours, approximately when the sun is high over horizon, and also it produces it's more efficient to use in the areas which are as close to equator as possible. So this is true. But also it should be mentioned that current technologies, they allow to enhance this technique a little bit, and they also could provide some solutions which could be used to collect sun energy even in more northern regions nowadays. So we can see that also amount of sun energy, it depends on the season. For example, here we can see that during summer time, during noon, we can receive the biggest portion of sun energy. But in winter time, the sun is relatively low over horizon, and it means that we can consume a lower portion of energy from the sun beams. And also this could be confirmed by the following chart. It shows sun path chart for 40 degrees north latitude, so it's close to current area, and we can see that depending on the season, so for example for June at noon we can see the highest sun over the horizon, and from this we can accumulate the maximum amount of solar energy with our panels. And with the winter, so December and January, the sun is not that high, and the amount of energy is relatively lower compared to summer times. And also we can see that the most effective time for using sunbeams, for converting sunbeams, is between 9 a.m. and 3 p.m. So all other time we don't have that much sun to cover and convert it to electrical energy. So how does solar electricity work? We use photovoltaic systems to convert light energy directly into electricity, and these photovoltaic systems, they commonly known as the solar cells. So solar cells, it's one of the very basic components of this technology, and we'll discuss a little bit later how does it work. So these cells, they are combined to some panels. The panels could be combined and build up and some solar fields could build up with these panels. And also it could be used as roof systems, as a field systems, or maybe for some very small home use compact systems. Also, we have to mention that over the years this technology evolved, and there are a number of generations of the solar panels. I must say that idea of solar panels first arises around 1970s, and during this time it was evolved also, and along with the evolution of this idea, it was provided evolution of photovoltaic materials. So during first generation, it was maybe early in the 1970s, maybe 1980s. It was used bulk crystalline silicon as a material to produce these cells. And this type of material and production was relatively high cost. Also, it was a rigid substrate, and typically it was used, and currently still it's used for rooftop solar systems, solar fields. We just saw on previous slide, and we can see here. So these are typical implementations, and also we can see now lots of solar panels within this first generation. So the second generation, it's characterized by the use of different type of material, such as cadmium, silicon, and some others. And these materials, they allowed us to produce so-called thin films. So it means that solar panels, they are not that big in dimensions. Comparing to first generations, they are much thinner. This technology allows us to provide not that expensive manufacturing. So final products with the relatively lower cost arises possibility of printing these panels, and it uses to build this type of panels, second generation, they used as building facades, window coatings, and other techniques where they can be installed, and that's why they could be used for installation, mainly installation and producing energy. And the last generation currently advanced is the third generation with the development of another type of materials, which could be characterized as they are mostly organic, and also it could be used in nanomaterials, which allowed to produce extremely thin photovoltaics, less than 100 nanometers thin, and also they are printable, so they could be represented as some kind of tapes which could be installed everywhere, and they also are more efficient comparing to previous generations. But as this technique is novel and advanced, so still there are some challenges and maybe relatively higher cost of this equipment comparing to previous generations. So one moment, please. For additional efficiency of photovoltaic panels, special geometric constructions could be used. Here we can see some of the possible approaches how to modify construction of solar panels to collect more sun energy from them. For example, the first one, we can see so all of these techniques, the idea is to concentrate solar power, and such systems they could use, for example, lenses, as with the first example, and the second example also, and the third example also, or mirrors, so-called reflectors, and so they could use tracking systems also to focus a large area of sunlight onto a small area of receivers. So what does it mean? It means that solar panels, they could trace the sun movement over the horizon and they should be turned to the sun with their face to collect the most energy they can from the sun. And also the use of mirrors, of reflectors, of special shapes of this collecting devices also helps to concentrate so-called power and produce energy in the most efficient way. So this is one of the ways how to advance it, to use special types of equipment and special types of construction to collect more energy from the sun. Benefits of solar energy, we already covered this question a little bit. So the energy from the sun is the most abundant from the energy available at all times. Sun's energy is there to stay and not diminishing like the reserves of fossil fuels, because sun, it's assumed it will exist some more years after our timelines lives, so still we can use this energy, let's consider for infinitely. And also it provides such benefits as energy independence. It could allow us to get lower energy bills, but also we have to consider the needs of initial significant investments into this technology. Low maintenance, it's not hard to maintain solar panels, and it doesn't cost too much. Environmental benefits, we told about this, and also it could help to add some value to your property if you have solar panels installed. So this kind of benefits. So zero emission, let's single it out once again. No noise pollution, no risk of explosion, fire and chemicals comparing to traditional energy sources. Low maintenance, we told about this. No running costs, so energy is free. Once we have installed the solar panels, we don't pay any single cent anymore. Let's consider this. And it could be independently installed, so we don't depend on centralized on energy companies, on some centralized energy distribution systems. So all is on our own. But still, there are certain challenges in the use of solar energy. The most important of them are that solar energy is not available at night. It requires a lot of land. Also, we have discussed it. It has a high initial investment. Also, we just discussed it. And also, the type of energy is intermittent. We have to consider it, and we have to somehow deal with this question. Okay. So the next question is also with the development of technology, when solar panels become more and more popular solution for energy conservation and the use within the idea of green society, the overall photovoltaic cost reduces significantly during last decades, and we can see that, for example, the cost of 1 watt produced by a photovoltaic panel, not panel but one cell, I guess I get better to say, it's more than twice lower comparing to 10 years ago. So in the early 2010s, it was cost about 3.12 US dollars per watt, but currently it could cost about 1.38 American dollars per watt to produce. And the most contributor into this overall cost was the price of the module itself. Initially it was 1.72, but currently technology developed, and the cost of the material dropped, and currently it costs only half a dollar to have a solar panel photovoltaic module. So over the years, it became more and more beneficial to use this technology. And here we come to construction of the solar cells, solar panels. So we have to admit that photovoltaic power generation employs solar modules. We can see one of these modules here in this picture. These modules, they composed of a number of solar cells. So we can see these cells in this module, and these cells contain a semiconductor material. And we discussed the type of possible materials such as silicon and other indium and other materials which are relatively rare, and that's why they are relatively high cost. So copper solar cables, they connect modules and arrays and subfields into bigger ones. Because of the growing demand for renewable energy sources, the manufacturing of solar cells and photovoltaic arrays has advanced considerably in recent years. And we could see it from the previous charts, with which could be explained by the drop in its cost. So photovoltaic module power is measured under standard test conditions in watts peaks. So it means that how much watts it could produce during peak load. The actual power output at a particular place may be less than or greater than this rated value. It depends on the sun intensivity, and also it depends on geographical location, time of a day, weather conditions, and some other factors. So solar photovoltaic array capacity factors are typically under 25%, which is lower than many other industrial sources of electricity. But also we have to understand that we get solar energy for free, in difference to other types of energy conversion devices. So the electrical efficiency of photovoltaic cells is a physical property which represents how much electrical power a cell can produce for a given solar irradiance. So the basic expression for maximum efficiency of a photovoltaic cell could be represented by the ratio of output power to the incident solar power, radiation flux times area. So the efficiency is measured under ideal laboratory conditions and represents the maximum achievable efficiency of the photovoltaic cell or module. But actual efficiency is influenced by temperature, irradiance and spectrum, and the location and all other factors we described previously. So solar cell energy conversion efficiencies for commercially available photovoltaics, as we previously told, is around 14 to 22, maybe 25%. So it's not that efficient comparing to some other types of energy converters or energy sources, but we have to take into account that we get this energy for free, so we don't pay pay nothing for this energy. So here we can see how this type of energy works. So for example, we consider this material silicon. It consists of some electrons, neutrons, and protons. The most interesting for us here are electrons, and the sun, could impact these electrons. They could force them to move from their orbits, and this movement could initiate electrical flow, and that's why we can get this electricity. So, for example, silicon solar cells, through the photovoltaic effect, they absorb photons from the sun and generate flowing electricity. So this process varies depending on the type of solar technology, but there are a few steps common across all solar PV cells. So first step, light is absorbed by the photovoltaic cell and knocks electrons loose, something like this. Uh, First, light strikes a photovoltaic cell, and the photons are absorbed by the semiconducting materials it is made from. Usually it's silicon in most of the cases nowadays. So this incoming light energy causes electrons in the silicon to be knocked loose, which will eventually become the solar electricity you can use in your home. The second step, electrons begin to flow, creating an electrical current. There are two layers of silicon used in photovoltaic cells, and each one is specially treated, known as doping, to create an electric field, meaning one side has a net positive charge and one has a net negative charge. So this electric field causes loose electrons to flow in one direction through the solar cell, generating an electrical current, and so that's how we have these currents at our homes. And the third step, the electrical current is captured and combined with other solar cells, and once an electrical current is generated by loose electrons, metal plates on the sides of each solar cell collect those electrons and transfer them to wires. And at this point, electrons can flow as electricity through the wiring to a solar inverter and then throughout your home. So this is the basic technology. So here we can see the composition, typical composition of a solar cell. So it's building a solar cell. So it's these two parts, silicon doped with phosphorus, which contain few extra electrons, and the bottom part, silicon doped with boron. So it contains some holes, because it contains few less electrons. Also, we have some wires on the top and wires on the bottom of this cell. To this wire, we connect our electricity system wires, and when sunbeam hits this upper plate, silicon doped with phosphorus, which contain a few extra electrons. These electrons could be wiped out from their positions, and they could start to move by these wires, and if they are connected to our home electricity system, they could generate some energy. So here typical chemical elements used in photovoltaic manufacturing, and this process could be described as follows. For example, sunbeam hits the electron, it goes through these wires, produce some electricity for us, and go back to its place. And so this process goes continuously. And so that's how we can get this electron move, which initiates current flow, and we can get this direct current in our wiring system. Okay, one moment. Okay, so let's go now. So this here we consider it the construction of a single photovoltaic cell, but um, single solar module, it can produce only limited amount of power. So most installations, they contain multiple modules, adding voltages or currents to the wiring and PV systems. Photovoltaic system typically includes an array of photovoltaic modules. So this one cell, it includes as a part into the solar module, and solar modules, they combined into solar panels. Uh, then it should be added with some additional equipment such as inverter, a battery pack for energy storage, charge controller, interconnection wiring, circuit breakers, fuses, disconnect switches, voltage meters, and optionally solar tracking mechanisms. So all these could be added, and all these combined could be considered as a photovoltaic system. So the basic elements, let's cover it once again, is the solar cell. We just discussed the basic principles of its operation. As a single solar cell produces very small amounts of energy, they typically combined into solar modules, which then are combined into solar panels. And these solar panels, equipped with some additional modules, they could be considered as an entire photovoltaic system, which could be installed into the household or to the enterprises, and could be used to generate some energy for you. So all this equipment should be carefully selected to optimize output, energy storage, reduce power loss during power transmission, and conversion during power transmission and conversion from direct current to alternating current. Yeah, we mentioned during previous slides that these cells, they produce direct current, but typically most of your devices at your household, they use alternative current for their work. So that's why additionally we need some converters from direct to alternating current for you. And each type of conversion or each type of energy transmission, all of these leads to losses. So we have to think how to minimize possible losses from these processes, from conversion and transmission processes. So module electrical connections are made with conducting wires that take the current of the modules and are sized according to the current rating. And panels are typically connected in series, as it could be seen here, of one or more panels to form strings to achieve a desired output voltage, and strings can be connected in parallel to provide the desired current capability, amperes, of the photovoltaic system. You see that with all this construction, we need a relatively significant amount, a significant area to locate this photovoltaic system. Also, we need some additional equipment to run all this system, and this system altogether seems a little bit complicated. So here we can see just a schematic layout of this system. So we have a photovoltaic generator built up with the use of these solar panels. Then energy goes to some controller. This controller have to analyze this energy, the quality of this energy. Then it also coordinates operation of interconnected devices to this controlling unit. So portion of energy they could sent to battery for storage, or if at the night time they could retrieve this needed amount of energy from the batteries. Also, controller with the use of inverter could transform this energy to alternating form and send it to alternating current users. Or it could be used directly from the controller with the appliances which use direct current for their work. So here we can see that except for photovoltaic system, photovoltaic generator itself, photovoltaic system also contains some additional equipment such as controller, inverter, and battery. So these are three main parts of the system, and let's consider them one by one. So battery, so voltage of the battery terminals, they changes during charging and discharging processes because the sun energy is not constant, and it's every time it's impacts on charging or discharging of the battery. So for fully charged, for example, PV acid cells, the voltage is about 2.12 volts only, and that's why it's should have significant number of discharging and discharging procedures. So during discharge, voltage drops. It's obvious, but during charging the voltage rises, and this rated value also changes often. So you might already guess that this continuous charging and discharging may lead to undesirable overcharge of the battery, and all these charging and discharging cycles, they also should be controlled because they also impact on the battery entire life. So to control all these processes, charge controllers used. Here we can see them, and here is the picture, photo of one of the possible solutions. Charge controllers, they maintain the voltage within the required threshold levels, minimum and maximum. Discharging and then charging back up to the state of charge at the start is called a cycle. So this device, they control all of these cycles. They have to be in the rated ranges. It is an electronic device. These functions are to reduce battery maintenance, topping up by controlling gassing, water loss, for example, during charging, to charge at preset voltages to prolong battery life and avoid damage to sensitize loads, to disconnect the loads at the preset voltages to prolong battery life threshold, to facilitate interconnection between modules, battery and loads, and system status monitoring and indication. So with the factors affecting the capacity of the battery, it is important that the battery is designed to match the operating and life requirements of the application. So therefore, there is a need for a control unit to control the discharging and charging process. So that's why, additionally, you have to think about this type of equipment with your photovoltaic system for your home. So solar modules and batteries, they operate with direct current, and this means that, for example, your mains electricity from your sockets at your apartments, for example, they typically, not typically, but all of them, they operate with alternating current, and also many electrical appliances, devices, and accessories are only available for alternating current. So To make needed conversions from direct to alternating, an inverter transforms inverter should be used, and these inverters, they transform low voltage direct currents supplied by solar system into high voltage alternating currents. The input of an inverter is designed for about 12 volts, maybe 24 or 48, depending on the solar panel construction, how it's wired, how it's coupled together. So all this influence on the value of output voltage from the solar panels. So this solar inverter, they consumes 12, maybe 24, maybe 48 volts of electricity, which comes from solar panels. And at the output, they produces 240 volts of alternating currents, which is typical for our grids. So these inverters are designed for standalone as well as for grid-connected systems, for different types of these systems. So these inverters, they tend to make systems more expensive, not only because they cost money, but they also consume some energy, making it necessary to increase system capacity to cater for these loss. So you have to consider that each time you add some additional equipment into your system, you will lose in energy, because each single piece of additional equipment, it also consumes some energy. So in general, we can see layouts of photovoltaic system could be represented as follows. So it could contain photovoltaic cells arrays, sun in sends photons to these arrays. They collect these photons, then send it to controller. Controller, they analyze this energy. They could manage this energy and maybe send some portion of energy to inverter to feed alternating current loads devices. Some portion of energy could be sent to batteries to store it, or receive the energy from battery when it's night time. And some portion of energy could be sent to direct current loads. So all this could be done by the controller of your photovoltaic system. So how to choose solar panels? You have to think about some questions before you selecting solar panels. First of all, you have to select the right technology. So the selection of solar panels technology generally depends on space available for installation and the overall cost of the system. You can install it in the field, maybe as a roof systems. So it depends on all this depends on your options, on your possibilities, and based on your possibilities, you have to choose type of the solar panels. Then also you have to select the right manufacturer for better warranty, because currently a lot of companies arise which propose their solar panels, but not all of them are equal and equally efficient. And we talked that the typical efficiency of solar panel varies between 12 and 25, let us say, percent. So it's better for you to use the more efficient solar panels. So you have to consider manufacturer. Then you have to check operating specifications beyond STC ratings. I think it's obvious. Then negative tolerance can lead to lower system performance and reduced capacity. So you have to carefully analyze all engineering before your solar panels installation, and also solar panel efficiency under different conditions and over time. You have to consider all this leads to the type of solar panels you are going to use. We talked about solar photovoltaic systems, But in reality, it could be different types of these photovoltaic systems, and let's say that it could be singled out three types of these systems, so-called on-grid systems, off-grid, and hybrid. So on-grid systems, they based on on-grid distributed. They are on-grid distributed. They grid connected and centralized. While off-grid, they off-grid domestic systems. They could be also off-grid non-domestic systems, and hybrid, they combined on-grid and off-grid systems. So what does all this mean? Means I will tell you right now. So first type is off-grid photovoltaic systems. These are standalone photovoltaic power generation system. They also known as off-grid PV systems. In the absence of grid area, the use of solar modules emit direct current charged by solar battery, charge controller for the use of electrical appliances. Then DC current energy of battery can be supplied directly to DC electrical appliances and other uses. Such a system can be called the DC off-grid photovoltaic system, and also battery is connected to off-grid inverter. It doesn't show here. And this inverter converts the variable direct current output of a photovoltaic solar panel into utility frequency alternating current that can be fed into a commercial electrical grid or used by a local off-grid electrical network. So it is a critical component in a photovoltaic system, allowing the use of ordinary commercial appliances. So solar inverters, they have special functions adapted for use with photovoltaic arrays, including maximum power point tracking and islanding protection. We cover this question a little bit later. So these off-grid systems, they have such a composition that they are used basically to feed entire house or home, which is isolated from the centralized grid, and that's why this type of system they called off-grid. So they use solar panel arrays, they use charge controller, and they use battery backup bank. So these batteries, they use to store some additional energy from solar panels, and to use this energy managed by a charge controller to supply the household during night time or during rainy day or during cloudy days. So all these systems work independently, and they do not depend on centralized grid power distribution system. So these are off-grid systems. So here another explanation of them. So they have solar module, charge controller, some battery bank, which goes to inverter, which could convert energy from direct to alternating current, and this alternating current could feed all appliances within your household. So advantages of such type of off-grid photovoltaic systems. So they meet the demand of grasslands, deserts, islands, and other areas, home use electricity, and achieved good results within these areas. The small decentralized off-grid power photovoltaic systems, especially building integrated photovoltaic power generation systems, they proved to be efficient because of the advantage of small investment, fast construction, small footprint, policy support. The off-grid photovoltaic system gradually become the mainstream, and I didn't see much of such systems here in Riga, but I know that, for example, in North America, it's quite popular for small households, and it's beneficial for them, and it's allow them to feel themselves more independent from the centralized government. And also in the USA, the government, they support the use of such a small photovoltaic systems for the households. So they pay them back about 30% of installation cost for such systems. What do you need to install such a type of a system? It's solar panels. We discussed it, solar controller, we discussed it, battery and inverter. So all these we have covered. So also we have to consider the following factors. So off-grid solar power systems, they design factors to consider to use them. You have to consider the following questions. So where solar power system is supposed to install. So it means that if it's some desert places or some island, it's the first type of use for these systems. So how is the solar radiation situation in this area? So it's obvious that it's not reasonable to install such systems within the very northern area within the polar circle, because half of the year you don't have sunlight this area, but the closer to some very sunny regions, it's very reasonable to install them. So the load the power of the system you have to consider and calculate carefully then your needs in the solar supply. So what is the system output voltage, DC or AC, you have to consider in order to choose proper inverter. How many hours the system needs to work per day? I think it's obvious question. If there is no sunlight or in the rainy weather, the longest days the system needs to continually supply the power for a daily use. So this question will, the answer to this question will give you information for correctly choose of your battery capacity and load conditions, purely resistive, capacitive or inductive, starting current much. All these questions you have to consider before choosing this type of photovoltaic system. So typically, it could be used, for example, for a solar home system. Generation capacity about 1,000 watts, 1 kilowatt. It could power such target facilities such as individual residential usage, such as lighting, TV, radio, lights, and also it provides advantages such as simple structure, very suitable for living in scattered villages. It is more accurate because it uses a single household. So all of this goes to your choice for off-grid photovoltaic system. So, and here is a brief example how it could be used for some household which consumes in total about 468 watt hours of an energy. It includes TV set, satellite TV receiver, lightning, and some other maybe appliances. You need solar panel which produces 1 to 150 watts at peak load. And also it could this set of batteries. So you need to use such type of batteries, you need to use such type of inverter and charge controller for 6 amperes, and also such system could allow you to use accumulated power capacity for 3 rainy days. So It's one of these examples how it could be calculated. And typical applications of these off-grid solar systems are living in remote areas without electricity. We discussed this for electricity lighting, television, washing machines, and other household electricity. Photovoltaic pump without electricity, so such as deep wells for drinking irrigation, traffic lights in the field, beacon lights. I don't know how about here, but for example, in hot areas such as Turkey, Greece, it's a very typical solution. They use this of grid systems to power their traffic lights or rail lights, traffic warning, marker lights, street lights. So all this is already used there. Auto ancillary solar car, electric car, it could be used for these purposes. Aerospace instrument satellites. Yes, I think you saw this type of panels. Communication, telecommunications field, solar unattended microwave relay stations. Also, petroleum, marine meteorology, oil pipelines and reservoirs, gate cathodic protection, solar power systems, oils, rig health systems. All this could be a target for this type of energy use. Life and emergency power, marine testing equipment, meteorological, hydrological observation equipment, etc., which located in some remote areas, and other portable appliances, desalination equipment and power supply. So all these could be targets for these off-grid systems. So the next, another type is on-grid photovoltaic systems. So from this chart, you can see that portion of generated energy which comes from solar panels, it goes to supply your home appliances, but other portion could go to central grid. And you can see no batteries within this type of photovoltaic system construction. So in this case, grid-connected photovoltaic power system are power systems energized by photovoltaic panels, which are connected to the utility grid. Grid-connected photovoltaic power systems, they consist of photovoltaic panels, solar inverters, power conditioning units and the grid connection equipment. And unlike standalone photovoltaic power systems, these systems, they seldom have batteries. When conditions are right, the grid-connected PV system supplies the excess power beyond consumption by the connected loads to the utility grid. So if they produce more power than your household need, all extra power could be sent to the grid, but at the night time when you need some power for your home appliances, you see you don't have battery, you can get this energy from the central grid. And within such trading system, you sell portion of your energy at daytime, but you consume some portion of energy from the grid at night time. So eventually you are going to be beneficial because the amount of produced energy, typically it's higher than the amount of energy you are going to use at night time for your household. So here is another explanation here of this principle on grid PV system. Also it could be not it could be, but it should be used utility meters, which needed to calculate how much energy you have sold to the energy company and how much energy you have consumed from the energy company. So that's why this equipment also should be considered as an additional units for this system. So features of this on-grid systems, solar energy gathered by photovoltaic solar panels intended for delivery to a power grid must be conditioned or processed for use by a grid-connected inverter. So inverters should be must have for this type of a system. So this inverter sits between the solar array and the grid. They draws energy from each, and maybe a large standalone unit, or maybe a collection of small inverters, each physically attached to individual solar panels. So these inverters. This inverter must monitor grid voltage, waveform, and frequency. One reason for monitoring is if the grid is dead or strays too far out of its nominal specifications, the inverter must not pass along any solar energy into such type of a grid. So inverter also connected to a malfunctioning power line will automatically disconnect in accordance with the safety rules. And another reason for the inverter monitoring the grid is because for normal operation, the inverter must synchronize with the grid waveform and produce a voltage slightly higher than grid itself in order for energy to smoothly flow outward from the solar array. And all this should be done by the inverter. So here is example of one of the possible DC-AC inverters. So this device can convert the DC power into AC power because the current the solar system generate is a direct current, as we told, and the general loads are AC loads. So the inverter is indispensable, and grid inverter is used in the on-grid solar power generation systems. It can feed the electricity generated by the system into the national grid, and you must have this thing within this approach. Also, it have to ensure anti-islanding. So islanding refers to the condition in which a distributed generator continues to power a location even though power from the electric utilities no longer present. So it means that a kind of island appears within an energy system. So this islanding can be dangerous to utility workers who may not realize that the circuit is still powered, even though there are no power from the electrical grid. And for this reason, distributed generators must detect islanding and immediately stop producing power, and this is referred as anti-islanding. So in this case of utility blackouts in a grid-connected PV system, the solar panels will continue to deliver power as long as the sun is shining, and this is the reason why these energy islands could appear and why this could be dangerous. So the inverter have to deal with this question also. Advantages for on-grid solutions. So grid-connected photovoltaic power systems will reduce the power bill, as it is possible to sell surplus electricity produced to the local electricity supplier. So we discussed this example. At daytime you sell energy, at night time you consume energy, but in general you can be beneficial because during nighttime typically you use much less energy comparing to amount you have produced for the daytime. So grid-connected PV systems, they are comparatively easier to install as they do not require a battery system. Grid interconnection of photovoltaic power generation system has the advantage of effective utilization of generated power because there are no storage losses involved, and the photovoltaic power system is carbon negative over its lifespan, so as any energy produced over and above that to build the panel initially offsets the needs for burning fossil fuels. So even though the sun doesn't always shine and any installation gives a reasonably predictable average reduction in carbon consumption, so in general the use of solar panels help us to reduce emission to our environment. So typical applications of on-grid systems could be considered as the following: photovoltaic power plants, Typically, in North America, I saw such a plants when you fly over deserts. They use the deserts where it's very hot all the time and nobody live there. So you can use all this area to install photovoltaic systems there, and this is one of the main implementation of such on-grid systems. And also solar buildings. So these buildings which are covered with the photovoltaic panels, and they have some special construction which allow them to accumulate the biggest portion of solar energy during the daytime. And this is another typical example of on-grid system usage. Difference of off-grid and on-grid systems, I already think that you guessed about them. So off-grid system, they can be used in every place because it has a battery to back up, while on-grid system, they should get connected to national grid. Off-grid systems, they are expensive than on-grid because they need battery cost, and they need a lot of battery sets, and battery have lifespan for 3 to 5 years mostly, so you have to replace it. So on-grid system, the user can sell the additional electricity generated from the system to their country, so they all can make profits for users. When it is night, the on-grid system, they cannot supply power. Users should turn to the national grid for electricity, but in fact, if you generate too much energy at daytime, you sell to national grid when you need, you can get from them, but when it is out of power, it cannot supply energy. So it could be beneficial for one on one hand, but on the other hand, it could have some problems for you. When it's blackout in national power system, and when it is raining or at night in an off-grid systems, you can use the energy because the battery can supply you energy no matter it is out of power or raining. But in on-grid system, you are not able to use this energy. And as evolution of this system, it could be proposed hybrid photovoltaic systems. It's a type of a hybrid of on-grid system with the use of battery. And in this case, you have to spend much more, a little bit more money for installing batteries, but you will not depend on the grid, on the centralized grid during blackouts or during night time. So you can just sell additional energy, but rely on your battery and have constant power supply for your household with this hybrid system. So how does solar electricity work over time? Let's consider briefly fast short examples. So for example, during night time, when this is night, we consider, for example, this time 4 a.m. You consume power from the grid to supply all your appliances, and you consume nothing from the solar panels because you don't have sun, and your inverter is off, it doesn't work. And this is how it happens at night time. But then at 8 a.m., for example, you have some amount of sun. Your PV panel start working, and you can use some energy from grid, main portion at those times, but already you can use some amount of energy from your photovoltaic system to power a portion of your appliances at home. Then at around at 11 a.m. Sun gets higher, and you can produce more energy. So with this energy, you can supply almost all your home appliances, and only some portion of them you can use energy from the grid. So, and this control element is used to distribute this energy over your household. Next is 1 p.m. The most intensive sun shining at this time approximately. So you receive enough energy from your solar panels to feed all your appliances and also to send some amount of energy backward to the centralized grid. So you are selling energy at this time. And this is typical structure of this on-grid or hybrid grid photovoltaic system. Also, we can consider the following scenario. When here we have utility which supplies power to the transmission lines. Then we have a number of power distributing systems to the neighborhoods, and when it works, energy distributed within these systems in the similar way to explained here. But if some of the households they are going to install their solar photovoltaic systems, they could have enough they could produce enough power to supply their households, and also with the use of this centralized distributing system they can send some amount of energy to their neighbors. So that's how we can just we can just redistribute energy flow within our system and make the less load on the centralized grid. So this is how it goes in reality, and here we can see that we can use combination of renewable energy within the traditional ones. Types of energy. So in general, I have to finish. So in general, I have to conclude that the use of solar energy, it's a promising area for not research currently, not only research currently, but to consider it as some solutions for green society, to reduce possible pollutions to our environment, and also it could be beneficial for end users because with the use of these solar panels you can first of all, once you have invested in this technology, you can get free energy for years with your appliances on a local level, on so-called off-grid power photovoltaic systems, and also with the use of on-grid photovoltaic systems, you can receive another benefits. You can at the same time power your appliances, and also you can maybe sell some portion of produced energy to the central grid and make financial benefits from trading, from electricity trading with your government. So I think our time is up for now. Let me find. So I stop recording.